Good morning. This morning I'm going to cover COS2611, which is Programming Data Structures. And this one I'm going to cover is May, June 2016. The exam paper, it's going to be just one simple question. It's going to be on binary trees. So first I'm going to cover the binary tree definition. Binary trees definition. A binary tree, T, is either empty or such that T has a special node called the root node. Number 2, T has two sets of nodes, the left node and the right node, called the left subtree and the right subtree of T, respectively. Left and right are binary trees. Okay. In a PreOrder traversal, you'll notice that I've labeled these numbers 1, 2, and 3. You'll see them over here, 1, 2, and 3. And I've also put 1, 2, and 3 over here, where you've got the node, the N for node, the L for left, and the R for right. And why I've done this is I've put here pre, so that you can notice how the node is basically in the beginning, which is where the pre part comes from. So it says here, in an PreOrder traversal, the binary tree is traversed as follows. Visit the node, which is the first one, okay. Traverse the left subtree, so it will go to the left subtree. Traverse the right tree, and it goes to the right subtree. Okay, so that's the order of how you do the traversal. But don't take this arrow. This arrow obviously should have come from the node to the right, but I'm showing it in this order so that you got this image of going from the main node to the left, doing the left traversal second, and then doing the right traversal third. So I've made notes at the bottom over here, and I've said I will use the following keywords: L for left, R for right, and N for node. Okay. Note 2, take note of where the N is located based on the following keywords: pre, in, post. I've also organized this PowerPoint in this specific order because the interesting thing is you'll notice that the pre part we start with here, and it's at the beginning. The in part, you'll see, the node will be in the middle, and the post part, the node will be on the right hand side, or the very afterwards, the last thing. So let's go on to the next slide. So InOrder traversal is exactly what I was telling you. The node is in the middle. So in an InOrder traversal, the binary tree is traversed as follows. We traverse the left subtree. So we first tackle the left subtree, then we go into the middle one, and then we go into the right one. So it says visit the node, which is the main top one here, and then traverse the right subtree, where we're traversing over here. Okay. So the notes 1 and 2 are exact repeats of what is said previously, where you just monitor where this node is going. And as I've said, the slide is arranged in pre, in order, and post order traversal, so that it helps us remember these things when we're going through the exam paper. So here, a post order traversal, basically we start from the left hand side, we go to the right hand side, and then we go to the root node. And there's where I've put post. The node is right at the end. And then I've said that is step number 3. So for post-order traversal, in an post-order traversal, the binary tree is traversed as follows. Traverse the left subtree, traverse the right subtree, and visit the node. Okay. Notes 1 and 2 are from the same as before. Left, right, and node. Okay. And then you just remember pre, in, post. Okay. So now we get on to question 7.2 of the May-June 2016 exam. Basically, I've highlighted some steps on the left to try and help us solve this and break it down into smaller steps. So what happens here is it's saying that we're given a pre-order traversal set of strings, and we're given an in-order traversal set of strings, and we now need to draw the tree. Okay. So the first step is to mark the first element of the pre-order result as it is the root node. So that's what's nice with pre-order. We know that the first letter means it's the root node. Whereas when it comes to in-order and post-order, it can be a bit more complicated, because post we know is right at the end, and in-order is normally in the beginning. So if we're using from a pre-order to an in-order, we can easily identify where the middle one is. So the second step is to mark the root node in the in-order result. So you can see here I've marked the pre-order and I've marked the root node of the S order. So that's why I've said here step 1 and 2. So step 3 says the root node will divide the in-order result into left and right subtrees, respectively. And so if you have a look there, the in-order one, we're going to have the LON on the left-hand side. So I've marked it here. There's the node, there's the left-hand side, and there's the right-hand side. But remember, in-order means in the middle. And then pre-order, it's at the beginning. So thanks to this in-order, we're easily able to identify what goes on the left subtree and what goes on the right subtree. So that's how I've done step 3. And then the last final step is draw the tree. And then we continue to repeat these steps until we've tackled all of these letters, all these characters of the string. Okay? So the next step was to first identify the root node. Okay, that's what we had in our previous step. So we've done that. We've identified it as S. So I've marked it as S. So that was the first one. Then I've gone and I've split the pre-order on the left-hand side here, which is the OLN. And then I've also split the in-order, which is the LON. Okay. Then on the right subtree, we've got TBAD and we've got TABD. Okay. So that's the third step. Okay. After that, well, why is it not moving? Okay, yeah. After that, we can now break down on the left-hand side. I'm taking the left-hand side first, and so we can now find what is the root node between the OLN and LON. And as we know, on the pre side, the first character should always be the root node, and on the inside it should be in the middle. The root node is in the middle. So we are able to easily identify which one goes left, which one goes right, and here we've got left and right and middle. So basically I've said number 1, we've got the root node, which is N. Number 2, we got the left-hand side, which is the L. And then number 3, the step 3, we got the N, which is on the right-hand side. Now on this side, we're a bit stuck, because now we've got TBAD and TABD. So if we take into consideration pre and in, we can see that T is over here, but there's no middle T over here. So now how do we deal with this thing? So I've posted a question to the lecturer to try and find an answer. But in the meantime, I was mulling it over in bed, trying to think, how can I solve this kind of situation? And I've realized that if I drop the T, I've got 3 letters, and that gives me my pre and my in. So from the next slide on, you'll see I've made use of that. I've highlighted I've dropped away the T, and I've highlighted the pre-order route and the InOrder route, and they tally up. So with the InOrder, we remember that the left-hand side gets divided and the right-hand side is divided because we found the route. So now I know that A and D need to be on the left-hand side of B, and on the right-hand side of B is the D side. Okay. So I was looking at it and I thought, oh, okay, well, T is common in both of them. So there's obviously no other elements. So that T must be a root, another root node. And so my final answer is how I get to this answer. First, I take the T out, which I've done, and I've made it as an additional node. And then what I do is I go on to the next root node, which we identified was B. And then from B, I went and I put my left node, which was an A. And then I went to my right node, which I defined as D. And so that's how I managed to get to solving question 7.2 of May, June 2016. I hope this video has helped you and helped you to understand how to break this steps down a bit better. I wasn't able to understand it from the textbook, and so I'm just hoping that this video might help others that also cannot interpolate it from the textbook. Thank you for watching this video. I hope that it has been useful and helpful to you. Good luck with your exam. Goodbye.